markets. What do you think is holding up the adoption and the progress of graphene?
It would be awareness. Most people understand what graphite is, but they don't have any idea what graphene is. Graphene is carbon. It's an allotrope and has amazing properties when it's in final form.
I think with the proper capital, maximum $30 million, we would be the global leaders in graphene and graphite.
I'm Don Toporowski, and I'm the CEO of ReThink Mining, where we're always on the hunt for the latest technologies to help us tackle the toughest challenges in mining. And today I have two guests, David Fisher and Gary Van Dusen. They're the co-founders of Bio Graphene Solutions. You might not have heard about graphene, but it is an amazing material with all kinds of properties and potential. We're going to talk about a couple things today. The first is going to be, is there opportunities for mining companies in the production of graphene? And the second is, can they use graphene to make their operations better, more efficient, more productive, and more environmentally sound? Welcome, gentlemen.
Pleasure.
Thank you.
The thing I'm always interested in is, how did you hear about ReThink Mining and what prompted you to reach out to us?
I believe I found ReThink Mining on LinkedIn, and I know that graphene and graphite has some applications in the mining space. And obviously you're innovative, and I've had some tough time getting attention from the mining industry.
Well, you're not alone. And it's a thrill for us when people from outside of mining reach out to us, because one of the things we're trying to do is bring new ideas into mining, new technologies that can make their operations better. And once I got to know the two of you and visited your plant and learned about graphene, I was amazed. So I'm happy to have you here. There's three particular opportunities for miners in how they can use graphene to make their operations better. But let's first talk a little bit about what is graphene exactly?
Graphene is carbon. It's an allotrope, and the form it's in is similar to, you would have coal or diamonds. They're all carbons, but the graphene comes in sheets, and it is carbon attached to carbons and has amazing properties when it's in its final form and added to so many products.
So when you say it comes in a sheet, I was imagining initially a sheet, I don't know, like a sheet of steel or a sheet of wood. But actually, when you say sheet, this stuff's only an atom thick, right?
That's right. It is an atom thick, and it's approximately 0.32 nanometers thick, which is less than a millionth of the thickness of a hair. So yes, it is very, very small. If you hold it up to the light, a sheet of this, you would actually see through it.
So I did a little bit of research on graphene to try to get up to speed with the two of you. And I also talked to a couple of my friends about it. And they were cynical. And one of them said this: graphene is the material of the future, and it always will be. So I heard it was discovered only 20 years ago. And the two guys who discovered it, they discovered it in 2004. 2010, they got a Nobel Prize for its discovery. 20 years is not very long, right? And yet, we don't see it in our daily lives. What do you think is holding up the adoption and the progress of graphene in our world? Or the use of graphene, I should say.
It would be awareness in the public. Most people understand what graphite is, but they don't have any idea what graphene is. And graphene, if you want to use an analogy, would be, graphite's a book full of sheets. And if you pull a couple sheets out, that's the graphene part. And that's where chemical magic happens.
Yeah, I think there is an awareness problem, because I'm one of those people. I've dedicated my whole life to finding new and interesting things that might change the world. I never heard of it. Of course I heard of graphite, but graphene, I didn't know what it is. So how is graphene, I guess you explained how graphene is related to graphite. But where does graphite come from?
Graphite historically has been mined. It came from deep under the earth when carbon molecules were exposed to great pressures and great heat. and it allowed it to convert into the carbon form, which is called graphite, which is sheets, but many millions of layers thick. Unfortunately, for today's industry, they use it only for specific applications. But if they were to remove just a few sheets of that, the number of applications would expand exponentially.
Graphite mining is a tiny little market, right?
As for the number of miners, yes, compared to mining of iron ore or precious metals or manganese or zinc, it's very small.
And yet, I heard that the amount of graphite in a battery is more than the amount of lithium. Could that be true?
That's correct. Yeah, it is. If, for example, you had 1 kilogram of lithium, you would have about 2 kilograms of the anode material, which is a graphite. But that's more of a specialized graphite, one that is the battery industry does not really appreciate. They prefer more something synthetic to allow for fewer impurities in their battery.
So this got us to people starting to produce synthetic graphite rather than mine it.
That's right.
Correct?
Yes.
And I understand that now, of all the graphite that's produced in the world, half of it is produced synthetically rather than being mined from the ground.
Yes. But there is still at least 1 million tons a year being required for the graphite industry. So that is a lot. And the battery industry and applications for the batteries is growing exponentially.
And how does, I don't know if synthetic graphite is the right word, but how does synthetic graphite, if I can call it that, compare to mined graphite? Are there differences in it?
Chemically, when they finish it, it will be identical. If they remove all the impurities from the mined graphite, it'll be identical to the synthetic graphite. But getting there is a whole different story. The natural graphite, which is mined, does not resemble the purity of the synthetic material. But the synthetic material comes from some very nasty feedstocks.
Like what?
It's a byproduct of petroleum coke. And it has to get heated up to over 2,700 degrees, and it has to be cooled down at a very, very slow rate.
So
it's a very there's some regions in the United States where they don't allow it.
So tell me what petroleum coke is.
That's a byproduct from the petroleum process. That's when you get what you want out of it. That's what's left. And out in Alberta, for example, we have many stockpiles of that just sitting there, waiting for an end use.
So making something useful out of it's probably not a bad idea, but that process is dirty, not environmentally sound, right? Like
That's right.
In what ways is that?
Well, the gas is coming off, and the energy needed, it's such a huge carbon footprint that, fine, you can make the product, but it's not very environmental.
So this is what I was thinking. This might be a crazy idea, but after I met the two of you, I was thinking about diamonds. And when artificial diamonds first came out, the diamond producers, the producers of natural diamonds, believed no one will ever want it. They're going to see it the way they see cubic zirconia. It will never be valued the same. It'll never be treasured. Forget about it. But in reality, according to The Economist this year, 20% of the diamonds sold in the world now have been artificially produced. So what I was thinking, if I was in the mining business and I was looking to open some new mine that was going to take 20 years, a lot of headaches, and $1 billion, and someone said, well, why don't you just make diamonds instead of opening a new mine? It seems like it would have been really wise to jump on that opportunity. So now I'm thinking about graphene that has a huge potential market, limitless applications, super unique properties, nobody producing it in quantity, and the ones who are doing it in a way that is not very good environmentally. Why wouldn't I just give you guys like $10 million? You open up a plant and double the world's production of graphene. And now I'm not in the business of mining digging resources out of the earth for people. I'm in the business of producing a green product for the world to use without a 20-year wait and without $1 billion. Would that be nuts for a miner to think like that?
We've actually had one of our early investors was a graphite property in the United States of America, where they have not mined graphite since 1953.
And he's trying to reopen it, is that right? And not succeeding?
Yes, he's getting environmental roadblocks put up one after the other.
So tell me how the production of your graphene is different than what all the other guys are doing. Somehow it's green. Is that right?
That's right, yes. It comes from a plant source material, which you can grow every year. And the product is processed in a thermal and mechanical procedure, and it allows us to convert the carbon, hydrogen, and oxygen that is naturally available in the plant material, and it converts to a final product, which can either be graphene with oxygen or graphene without oxygen, which would be, we have a term for that, but it could also produce a graphite, a synthetic graphite from the same material. So we have several paths to go on that if we choose to, but it's all organic.
So your feedstock is organic, it's plant matter.
Right.
I guess we would get it from nature or farm it. But what about the waste from your process? What sort of environmental hazards are you creating by producing it?
Well, any of the excess material coming off is fed back into the thermal process, and under those conditions, it allows it to grow into graphene also. So it's a very closed loop system here with minimal loss, and the byproduct would be hydrogen, which when burned with oxygen would be water.
And I guess the only input aside from the organic matter is energy to basically char it?
That's the best description of it. You're forming a biochar, which is done at various temperatures. We would take it and produce it further at elevated temperatures and conditions. Just as you do in producing a biochar, you don't want to burn your material, so you control the conditions that you're producing your biochar in, and that's what we're doing. We're taking a product, forming the biochar, and going further into it to produce the final product, which will be a graphene or a graphene oxide or graphite.
So it sounds like your process is nice and green. There's nothing for anyone to complain about. Could we put this plant next to a schoolyard?
Yes, but I think the zonings, they don't allow too many buildings, industrial buildings besides schoolyards. But it could be certainly put into most communities there in their industrial zones.
I understand you can produce graphite or graphene.
Correct.
If you take those products that you produce and compare them technically to the products produced artificially by others and to those extracted from the ground, how does your product compare to those?
They'd be very similar. Chemically, it's similar because it is just carbon and oxygen, and the configurations are similar in both, whether it's synthetic or mined. It's the impurity levels, though, that are found in the mined material which cause the issues, or even left over in some of the synthetic processes. There's impurities in there that when people want to use it in their product, it may cause another reaction there that they don't want to see. With the graphene, it certainly adds strength to whatever they're doing, whether it be in coatings, plastics, concrete, asphalt. It adds strength, but if there's impurities in there, it may distract from that.
So is there one process that produces fewer impurities than another?
Our process.
Our process,
Your process.
yes.
If you look at a typical mine product, the material is going to differ from one vein to another vein. Because our material is a commodity, it's made for human consumption, it's 99.9% pure, so our output is always that pure because our input is pure.
So other people have called graphite a critical mineral. I don't know if they call graphene a critical mineral, but I understand people who are working on batteries right now believe that using graphene instead of the more common graphite, we can have a much better battery. Is that true?
Yes, it is. The advantage of having graphene over graphite is that when the graphene is in the battery, it allows for very quick charging and discharging. They were calling those not so much as a battery, but as a supercapacitor. And I believe there's a company over in Northern Europe who's working with this kind of material right now from a different non-organic source, but they're producing graphene batteries, but they're really supercapacitors. And so is China also now.
I know you guys feel alone because you have this company, right? You're trying to raise money. You're trying to get people to believe in it and invest in it and to help you move forward. But there's a lot of people outside of you two who really believe that graphene is the material of the future. One of those groups of people, they're senior policymakers in the European Union. And what they've decided is that they are going to invest €1 billion over the next 10 years to developing applications for graphene. Like, what do you think are the biggest potential applications? Just forgetting about mining for a minute, but the biggest applications of graphene in the world in the next few decades to come?
Definitely in concrete.
Concrete, I think, is one of the largest applications along with asphalt. Concrete is the second most used material in the world next to water. By 2050, the world is going to double its built footprint. There's no getting away from the concrete.
They say right now concrete produces 8% of the world's greenhouse gas emissions.
Mm-hmm.
Yes, through the production of cement it does, yes.
Through the production of cement. So how could this technology reduce CO2 emissions in cement?
Direct addition into the cement admixtures when they're making the concrete allows the concrete, when it cures, to be stronger by 25% stronger. But it also allows them, if, for example, they're saying they need to set a mark of a certain strength for their concrete, and they've more than reached that with adding the graphene, they can reduce the amount of cement they started with in the first place and have an additional savings on top. So it's a win-win.
So that's going to bring us to the applications of graphene in mining. And I think we'll talk about 3 of them in particular, but the biggest one has got to be the introduction of graphene into the cement they're using when they backfill.
Yes.
I talked to my colleague at ReThink Mining. I'm like, come on, how much concrete is really used in mining or cement? He's like, a ton. And a lot of mines will have cement plants right on site, and they'll pump it in as they backfill and put their waste back in. So tell me how the introduction of graphene into that cement would change things exactly for them. Like in terms of the characteristics of the cement, potential cost savings they could have, and how it might affect their production.
On the cost saving side of it, if we're removing 15% of the cement, so call cement being at $225 a ton, we pull that out, 15% of it, and we're adding the volume back in with gravel and aggregate, which for a miner would be probably pennies a ton because they'll have it sitting on their site.
So they could have a huge savings over time in the quantity of cement they use. We use less because we've added graphite. But the other thing I'm imagining is that if they were using enough cement, it would actually have a measurable impact on their CO2 emissions. I mean, if they take credit for that, right? Using less cement, that reduction in CO2.
Yes, we're finding that in the construction industries, they're seeing that they're reducing their carbon footprint and, of course, the greenhouse gases, because reduced CO2 by not using as much as the limestone. They don't calcine it. They don't need as much. So that calcined limestone, the CO2 coming up, that's half the weight of the cement itself. So that's a huge savings.
When graphene is present, the concrete sets in 7 days instead of 28, or reaches maximum strength in a quarter of a time. Is that right?
Depending upon the form of the graphene that's being used, depends upon the amount of, the characteristics in this case here, whether it's a graphene with a lot of oxygen or reduced amount of oxygen on the edges of its sheets. So it depends. And it also depends on how much they'll be adding. Sometimes they hit the upper limit. There is an actual upper limit for adding graphene, and that's the thing. So you can add a certain amount and get the effect you want, or you can add some more, but at a certain point, it doesn't do anything else. It's like excess vitamins. In fact, it may be not very good.
But really, when I'm adding graphene, I can choose between having increased strength or using less cement.
Yes, yes.
Right.
The other thing it will do is because of the size of the flakes being used, of the graphene in there, they will prevent the water from penetrating as deeply as they normally would without any kind of graphene in there. So it's a real advantage. For example, you're being exposed to salt water or water, first of all. It's going to stop the penetration in there and destroying the concrete.
Yeah, I thought that was really valuable for buildings and bridges and things like that. I was trying to imagine how reduced water infiltration would help in mining. I just think like once the concrete's down there, like it's holding it long enough that they can mine under it again. I'm not sure how important strength is in the concrete that miners are using, but maybe there's someone who's listening who will let us know. Do you have any idea?
We're both from the mining background, but unfortunately we don't have the cement with the mining background information. We don't have that available to us, but we certainly would be looking at working with somebody who does.
The one that I found really interesting, has nothing to do with mining, is that apparently if you add enough graphene, you can make concrete conductive. Is that right?
That sounds very George Jetson.
It would have to be the form of the graphene without the oxygen.
Okay.
That would be the case, yes.
I was thinking of if there was a way to use it for dynamic charging. You're driving down the road and at the same time you're getting charged.
Oh, you mean putting graphene into the rubber tires and into the asphalt? Yes, that's been discussed.
That's probably not on the top 3 applications today.
Not today.
So are you making any progress in convincing miners to try adding graphene to their concrete?
We actually have a full commercial scale trial going to be happening this fall with a mine in Northern Ontario.
Are you allowed to tell us who?
I have not discussed it with the mining company, but with the concrete company.
But it's in somewhere in Northern Ontario.
Yes, it is.
Yeah. And what do you think they're going to be trying out?
Backfilling a mine.
Yeah. And how are they going to measure its advantages or whether it's successful?
They will take core samples as they're producing the concrete, and it will go through the regular test like we do in our lab in Cambridge. So they'll be able to measure the increased strength along with the reduction of the cement that they require.
And how long do you think that test will take?
They'll do a 7-day, 14-day, 28-day, and a 56-day.
And you've been talking to cement companies. What do they think about the idea?
We've done testing with some of the global concrete companies, and we've had very good success. And with one in particular, we're having a business discussion with them. Now we're past the testing phase.
One of the things that they are looking at was the addition for using it for their clinkers as a grinding aid too, not just incorporating it into the concrete. So that's a twofold, which applies to mining, I guess. In that.
Yeah. So let's talk about the next application in mining of graphene. Apparently, somewhere around 3 to 4% of the entire world's energy that is consumed in crushing rocks, which is typically done in sag mills and ball mills. And you told me that if we add a little bit of graphene when we're putting our material in the mill, I can reduce energy consumption. Tell me how that works.
We have seen evidence of that in the concrete or cement-related industries in their clinker. When they form the clinker, it's a limestone, calcium sulfate, silica, and they form into little briquettes, and they have to crush them after it's been, of course, treated thermally. And they found that by adding a small amount of graphene, they were able to knock this energy cost down by about 16%, which is significant.
Those are big machines.
Those are big machines, yeah. And the hardness of, say, the limestone type of material is not the same as northern Canada's hard rock mining, but it's probably very directly related to that. So you put a certain amount of graphene in there with it, there's a very good opportunity to reduce some of the ball milling costs, the energy costs that are related to ball milling.
What do you think is the mechanism? Why does it reduce energy? What's happening there exactly?
I believe it's the theories around there, but it does appear to be it's distributing the energy and allowing the balls to stay cleaner. So it's metal on material. It's not metal balls coated with powder, and so the impact is not the same. It's basically 2 balls hitting each other, but they're both coated with powder. It's not the same as 2 bare balls hitting.
Do you know if anyone has ever done any tests on using it in a mill with ore, like gold ore? Or?
No, we have not had that opportunity yet, and I think that's open for discussion, though. That would be a very interesting application.
Yeah, like that's a massive amount of energy being consumed. If we were to find a mining company who said, hey, I'd like to test this, I'll give it a whirl.
Sure.
What do you imagine a test would look like where you're testing the effect of graphene on a milling process, energy consumption during a milling process?
Well, there's a few labs, such as the ALS people and SGS that the mining industry relies on. They would probably be very good candidates to send a sample over to their labs to provide them with a sample and run it through the test there. It should not be very expensive, but it would give indications.
But is there a test that doesn't use a ball mill? Like, I'm trying to imagine what tests would really compare to that, because that's kind of a unique process.
Well, they do have small ball mills,
Do
though.
they?
Yes, they do, for the lab size, especially those labs. They do. So it's the first step I would try.
So the cost really would be the cost to pay the testing lab, a bit of graphene and some rocks.
Yep.
Yes.
What do you think about the potential for that?
Well, we did talk to one of the cement companies, and they gave us an example of if you use our material as a grinding aid, they would save several dollars per ton in the energy costs, even with the cost of our additive going into it. They asked us that, can you be at least less than $3 per ton for the cost of your material incorporated into it? And then we got a business decision there. So this would be the same thing for the mined rock.
So there's one other area that I was fascinated by, how graphene could contribute to mining. And it was the recovery of dissolved minerals in the wastewater. Tell me how that would work.
We have, there's a lot of literature out there now about graphene in the form that this is. It's a graphene oxide. I actually specifically had reduced graphene oxide, so a specific amount of oxygen on the sheets. And when it's put in contact with a solution of dissolved precious metals, for example, whether it be gold, silver, palladium, graphene oxide has a very strong attraction to all those precious metals. And because it's different than the normal absorbent which they use in the industry, which is activated carbon. And activated carbon is a carbon, but consider it like a ball it's very porous, and it'll absorb a certain amount of precious metals on there. And when the pores in activated carbon, unfortunately, get covered with biofilm or something else, that's it. It's used up. Because graphene comes in sheets, you have the edges here, and the precious metals attached to them, and they stay on until you want to remove them. And so they don't get poisoned by the biofilm. In fact, graphene oxide is considered an antibacterial material, so it would kill that around that area. You would be able to collect the precious metals, and I do mean it's specifically attracted to gold in parts per billion, which is very good because that means you can put this into your waste stream in a chamber and like a sand filter sort of, and you can capture the last little bit of gold that you wouldn't have gotten with your activated carbon.
So maybe I would send it through that, let's call it the graphene filter, just before I send it to wherever I send my wastewater, the pond or whatever.
Yes,
Perhaps.
you could reprocess all the tailings.
Yeah.
Reprocess all the water in the tailings pond.
Yeah.
Well, that would be pretty interesting. And you're saying I can get gold out in what concentration? 3 parts per billion?
Well, in the parts per billion, yes. They said theoretically you could get it down for gold down to the parts per trillion, but that we haven't actually gone to testing of that, but there is literature on that.
Do we have any idea of what is the concentration of gold in a gold tailings pond?
You would not get 1 ppm, no. So it's in the parts per billion. So therefore, what you miss with if you ran it through activated carbon, you wouldn't get it. But if you ran it through the graphene, you get that. If you had to repulp your tailings and rewash your tailings, the water, any of the gold that didn't precipitate out would still be soluble, would be collected by the graphene.
So then now I'm imagining a vessel like a sand filter or a carbon filter. So now you got a vessel full of graphene with gold attached to it. Now what do you do?
As you would normally treat activated carbon, and you put it into your circuit and electrowin it out and reuse it again.
You had given me some figures where you thought that if we did this on a modest-sized gold operation, we could extract more than $1 million worth of gold.
Well, if you're losing right now 0.5% of your gold that way, some of the larger mines would experience some very major savings and recoveries.
Is that a test that you think is worth undertaking with a mining company?
Oh, definitely. I would.
Definitely.
Yes.
What other things are on your mind about graphene generally? Difficulties that the industry faces, the potential in mining. What else is there that we need to know about?
It's awareness, and it's also graphene has been identified as being useful in 45 different applications. We at Bio Graphene Solutions have tried very hard to be focused on our concrete, asphalt, and water filtration.
Like I had read as well that graphene is useful in water filtration. So we talked about how we could put water from a mine through it and collect the last residual or dissolved gold. How else can graphene be used in filtration generally?
It could be used in two forms. One, you put it on a membrane and it stays on, or the other one, which is part of our patented process, which is we're able to coat various substrate materials, and not just coating, but growing the graphene onto that. So, for example, if you wanted something a half-inch size, you would grow graphene onto that, and it would be a core of whatever it is, a silica or recycled glass. You'd have the core of that, but the whole surface would be the active graphene oxide. And that could be take a lot more abuse than they would, for example, activated carbon in their CIL or the CIP systems, and you wouldn't lose your gold by having the carbon break off and get lost in the tailings. So it's more durable and has a very strong coating on it, but it still collects the gold.
I talked to one of our members who's involved in the construction of roads for mines. I said, hey, I'm talking to these guys about graphene. They told me it's really good for asphalt. Is there any asphalt roads in mining? He says, no, they're too beat up. Forget it. I'm like, come on. There must be roads going from the town nearby to the mine, or it's not the big mining trucks, that the mining company must have paid for. If we had better asphalt, wouldn't that be useful to him? And he was really focused on the roads of the production vehicles. But tell us a bit about using graphene in asphalt. Because when I did my quick survey, there was a lot more enthusiasm for its use in concrete. And asphalt, the main, I would say, thing that discouraged people using it in asphalt was they said, it doesn't make much difference in asphalt when it's cold, but it makes a big difference in hot asphalt. Tell us about putting graphene in asphalt generally. So
we have been under a three-way collaboration agreement with ourselves, University of Waterloo, and GIP, which is Green Infrastructure Partners. And in a road, 5% of it is a bitumen, the binder. We added as small as 0.5% of our material, and we saw in between 18 and 23% less cracking.
Which would be pretty nice in a cold climate where once you get a crack, water gets in and wrecks your road, right?
Correct. North America is behind Europe when it comes to the graphene-enhanced asphalt. In the UK, on the A1 highway, going out of London, they're on their third commercial test. It's been used in a runway in Rome. They've done tests in Oman for the heat, because the graphene will help dissipate the heat very quickly. So it's being used more in other places in the world than Canada.
So I imagine if you start putting it into concrete, you start putting it in asphalt, we need a lot of graphene. So what could your company and your technology do compared to all the other people in the world who are messing around with artificial graphene in terms of the cost to build the plant and the amount of graphene that could be produced? How does your technology stack up against the alternatives?
I think with the proper capital, maximum $30 million, we would be the global leaders in graphene and graphite.
Okay, mining companies, you hear that? You want to be the global leader in producing graphene. It's only 30 million. I mean, that sounds like a great opportunity to me.
I believe it is a great opportunity.
So what do you think are some of the barriers that you're facing as a company attracting investors and attention?
The capital community or situation in Canada right now is very poor. We've spoken with other innovative companies, and they said you have to go to the States.
And what happens when you go to the States?
People will invest in the government, the infrastructure funds that they have down there. Everyone up here is talking a good story. We're just not getting the capital.
And I understand there was some interest from Mexico in your technology too.
Yes, we're very interested in working with the new administration of Mexico. Claudia Sheinbaum comes into power on October 1st. And we would look to facilitate and put a plant in Mexico, and they are looking to be the gateway for innovation for Latin America.
Yeah, you wouldn't be the first technology company to leave Canada for places where it's easier to attract investment. But at ReThink Mining here, our mining companies who are members, they're looking for things to invest in. So I'm hopeful that with the three things we talked about today, adding graphene to concrete to reduce CO2 emissions and reduce the amount of cement we use, using graphene to filter out the last little bit of precious minerals, gold, silver, palladium. And the third one, which was using graphene
as a grinding aid.
I'm hopeful that with those three things, something will catch the attention of these innovators amongst our members. And I want to thank you too for coming to see me here today and talk about this. I know you're from Cambridge or your plant's in Cambridge. I presume any company who's interested or any individual could come visit you there and learn more about your green production of graphene.
Certainly.
Our pleasure.
Well, thanks for being with me today.